The next operation we're looking at is products, multiplying radicals together. So if a and b represent non-negative real numbers, then the square root of ab is equal to the square root of a times the square root of b. And you can also read that backwards then. So the square root of a times the square root of b is equal to the square root of ab. So they have an example for us here. They've got two radicals here. They do have the same index. It doesn't say that, but that is an important feature there. They have to have the same index number on those radicals. And if you have that, then you can treat this as a single big radical here. So we can say square root of the first expression times the second expression. So big radical over the whole thing. So then we could actually perform that multiplication there. So 12 times 6 is 72. X cubed times x to the fifth is x to the eighth. And y times y to the fourth is y to the fifth. Once we have it like that, then we can break it down like we've been doing before. So the square root of 72, x to the eighth, y to the fifth, could be broken down, and it comes out eventually to 6x to the fourth, y squared, square root 2y. So I will leave that one for you to figure out. But we'll do these three examples together. If, however, talking through this, that made perfect sense to you, this would be the right place to pause this video so that you can try these three and then come back and see how you did. All right, for our first example here, we've got a number that is outside the radical, and our rule up here says nothing about that. So that one's just going to stay right where it is. The numbers that are inside the radicals, because they are both square roots, same index, I can write it together as one big radical. So this would be 2x cubed times 8x cubed y to the fourth. Okay, so now I could perform this multiplication inside the radical there. So I'm just multiplying the numbers, the coefficients of each of those factors together. So 2 times 8 is 16. And then I can put together my x's. X cubed and x cubed would be x to the sixth. And then there's only one y factor in there, so there's nothing I need to do to combine that. That'll just be y to the fourth. All right, from here, we're just simplifying this radical. So I've got the square root of 16 is 4. So I'm going to write that as times 4. The square root of x to the sixth, if I break that down, I would have 3 pairs of x's. So that means I could have x cubed. And y to the fourth, if I break that down, I would have 2 pairs of y's. So that would be y squared. And with all of that, there was nothing left inside the radical. So the radical is actually gone completely. So now all I need to do is just simplify here in the front there. That 3 times 4 would be 12. So this radical multiplication would actually just break down into 12x cubed y squared. Alrighty, next up, we have a couple of square roots again. They're both radicals with indices of 2. And we are multiplying. It says times between them. So my first move would be just to multiply, or turn it into one big radical, I should say. So that would be 50 times 2 underneath one radical. 50 times 2, of course, is 100. And then the square root of 100, that one's a nice even number. What times itself makes 100? That would be 10. Again, this one was a nice square root, so there's no radical left in my answer. It's just 10. For the third one over here. I have to choose my colors. All right, again, there's a little something that's outside the radical, and our rule doesn't tell us anything about that. So we're just going to keep that with whatever we do here, and we'll see what happens. We do have 2 radicals being multiplied. I can tell they're multiplied because it says times. So that means I can write it as a single radical with each of those radicands multiplied by one another. All right, now I can simplify what's on the inside of the radical by multiplying the coefficients together and multiplying the variables together as well. So 3 times 16 over 6, well, 3 times 16 is 48 over 6, and 48 over 6 is 8. Then I've got x cubed times x, so that would give me x to the 4th. And then I have a y also. So I made my radical kind of long there, but that's okay. This isn't my final step. The next thing I would need to do is break down this radical here, and we've had many lessons on that already, so I'm going to cut to the chase. So the square root of 8 would break down into 2 square root 2. X to the 4th, taking the square root, I would get x squared. And so that leaves me with a 2y inside the radical. All right, finally, I need to put these together here. So this is multiplication. I'm multiplying 1/2 times 2, which is 1, and x times x squared, which is x cubed. The 1 I don't have to write because it's not necessary. And so that gives me x cubed times the square root of 2y.